Hello everyone, in this video we'll be solving problem 172 factorial trailing zeros. The problem statement is we are given an integer n, we need to return the number of trailing zeros in n factorial operation. If you're not familiar with n factorial, we basically multiply n with n minus 1, n minus 2 until the number is 1. In example number 1, where n is given as 3, there are no trailing zeros. Because if we look at the n factorial value of 3, it's 3 into 2 into 1, which gives us 6. And as there are no trailing zeros, the output is 0. But in example number 2, where n is equals to 5, a 5 factorial total is 120. As there is one trailing zero, the output is 1. I hope you are able to understand the problem statement. There is one easy way of solving the problem, and there is one mathematical concept that we can use to solve it. So let's start with the easy way. In the easy approach, start a for loop with I is equal to n and decrement it after every turn. Use the global variable product and multiply it with n and save the output into the product variable again and let the loop continue. Once the loop is complete, that is n is less than or equal to 0, stop the for loop and check for trailing zeros in the product. We can simply use the mod operation to figure out what's there in the units place and accordingly return our output. As we are running this for loop until n is greater than 0, our time complexity will be O of n, where n is the number given to us in the input, and the space complexity will be O of 1, as we are only using this one variable to record the product of n factorial. This is one way of using brute force to solve the problem. Now let's discuss a different approach where we can use some mathematical formula. If we take n is equal to 5, the n factorial will be 5 into 4 into 3 into 2 into 1, resulting in total of 120, which contains one trailing zero. An interesting fact about factorial calculation is if the numbers have a 5 or a multiple of 5, there will at least be one trailing zero in the output. If you look at the output of 5 factorial, the output is 120, which contains one trailing zero. This is because there is one 5 in the calculation that we are doing. To simplify it further, 5 factorial, if we multiply 5 with 4, the output is going to be 20, and then any multiplication done on 20 will have one trailing zero at the end. It doesn't matter if we multiply 5 with 4 or any other number. As long as 5 is being multiplied with an even number, the output will always have 0 at the end. So this logic can be used in solving the problem. As long as we can figure out the total number of 5s in the value n, we can determine how many zeros there could be at the end of the output. Let's apply this formula to another example where n is equal to 15. 15 factorial is this huge number with 3 zeros at the end. Another way to put it is, because n is 15, if we divide it by 5, which will give us 3. So we can safely say that there will be 3 zeros at the end. I hope you were able to understand how we are using this logic to solve the problem without having to run any for loop and multiply the numbers to figure out the factorial. This is not an easy solution that you can come up with unless you have worked and solved several math related problems. It took me a while to wrap my head around this approach in solving similar kind of problems. With this solution, our time complexity is O of log n to the base 5. This is because we'll be running a while loop until n is divisible by 5. So we may need to run the loop multiple times if n is multiple of 5, like 25 or 125. And the space complexity is going to be O of 1, as we are only using one variable to record the total number of trailing spaces and updating the value of n after dividing it by 5. I hope you were able to understand the explanation. Let me show you how we can implement this using Python. Here's the solution in Python. I start by initializing a trailing zeros variable and set the default to 0. After that, I am running a while loop until n is greater than or equal to 5. Inside the while loop, we divide n by 5 and the quotient or the output is saved back into the n variable. And in the next line, we are adding the value n into the trailing zeros variable. We continue these steps until the while loop is running And once we exit out of the while loop, we return trailing zeros as our output. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 37% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.